looking at our 8B practice problems. So we're going to look at the bottom half of this first. The first 3 problems that you see on here on this sheet are not going to be on your quiz. So we'll do those after the quiz. But right now, let's talk, or we'll do them later, but they're not on the quiz. But problems like 4 and below could be in addition to what you see on your notes from last class. So starting with problem number 4, could it be a parallelogram? And again, you're using your notes from last class, and you're using those bullet points from your notes that we wrote next to the Venn diagram. There were 5 of them. And if you remember, we drew a little squiggly line, and we had that one underneath that I wrote prove to. So we kind of know in our notes what to reference. So if we look at those bullet points and we look at problem number 4, could it be a parallelogram, yes or no? Yes. Yes. It definitely could be a parallelogram. And what is the justification for why? Right. The diagonals cut each other in half, and so I believe what we wrote in our notes is that the diagonals bisect each other. Okay? So that's exactly right. We want to justify why we think it could be a parallelogram. Not what kind of parallelogram, because I don't know. Somebody said maybe it was a rhombus. Well, in order for it to be a rhombus, wouldn't the diagonals have to be perpendicular? That guarantees a rhombus, okay? But we don't have that, so we can't say rhombus. All we can say is just parallelogram. Looking at problem 5, well, that's a no, because we don't have both pairs of opposite angles. If we had the other pair of opposite angles also congruent, then that would be a yes. But because we only have half of the story, we can't guarantee it. Okay? Looking at problem 6, yes or no? It's a yes. And this is actually one, if you look at it, very similar to a picture that we did last class, isn't it? I think it's on almost the same picture from last time. And what's the justification? No? One pair. Gorgeous. Awesome, Angeline. So one pair of opposite sides is both parallel and congruent. I agree. Okay? Remember those arrows mean parallel, and those little tick marks do mean congruent. So I have one pair that are both parallel and congruent. We did that. I think I demonstrated it with exploragons last class. Okay, sure. So there's a difference between, it said exactly, right, on the checklist. The exactly refers to only trapezoids. This is the minimum information needed to prove it's a parallelogram. Once I know it's a parallelogram, I know this is true also, right? So it's all of them. But the minimum information needed to prove it is just that, okay? It's a little confusing. What do you think about number 7? Yep, it's a parallelogram. And what's the justification, Tess? You tell me, because I know we had talked about this. Right, so we really should say both pairs, okay, because we need both sets of them. So both pairs, like if we only had one pair of opposite sides, that would not be enough. We really do need both pairs, excuse me, of opposite sides are congruent. Okay, got to have them both. Good. All right, let's look at 8 and 9. We kind of already talked about 8, didn't we? So it's a yes, and what's the justification? Both pairs, got to have both, right? So both pairs of opposite angles are congruent. I agree, okay? All right, last one. Well, this one doesn't have the markings, but it has a bunch of information, so let's mark it what it says. So it says AE is congruent to EC, and then it says BE is congruent to ED. Wasn't that the same picture we had in number 4? So what is it? Yeah, and what's the reason? Good. The diagonals bisect each other. I agree. How do we feel? Any questions from the notes from last class? You will have on your quiz some sometimes, always, never questions. They may be the same, they may be different as the ones from your notes. Okay, but remember how we justified that, and we talked about that last time. Any questions about anything before we talk about 1 through 3? Okay. This, yes, after school today. That's a different question. Yeah.
According to sometimes and everything.
What do you get the answers to it, or?
No, just like a reminder of how it works.
How it works? All right. So sometimes, always, never. So if it's a sometimes, that means it could apply to one of the parallelograms, but maybe not all of them. So do you have, I'll just pick one, for example. Thank you, Tess, for letting me borrow yours. So it would say, I'm just going to pick some random one. The diagonals of a rectangle are blank. I'm going to pick a word. Congruent. So you have to write the word in there that's either sometimes, always, or never. So look at that particular question. It's not a sometimes. This is one that's not sometimes. Okay? The diagonals of a rectangle. So you want to think about it. They are always congruent. Remember when we built, if we have any regular old parallelogram and we try to upright it so that it looks like a rectangle, doesn't it make the diagonals congruent? We talked about that, right? So in a rectangle, they always are congruent. Now, I could change the question and make this, what's the other option? A perpendicular would be the other option, wouldn't it? So if I change this question and I said, all right, the diagonals of a rectangle are what? Perpendicular. Are they always perpendicular, never perpendicular, or sometimes perpendicular? This is the sometimes option, right? Because so in a rectangle, well, when are diagonals perpendicular? In a rhombus, right? So a square is a kind of rhombus. It's also a kind of rectangle. So because it's both, that's why it's a sometimes. The only option where this would happen would be a square, because a square is a kind of rectangle. Good. Does that help? Good. All right. So that's going to be your quiz. We'll do it after lunch, although if you are watching or listening to the recording, you pause it at this point if you want. Go ahead and take the quiz, and then you can resume the recording after the quiz. But let's go ahead and look at question firstly. All right. Let's go ahead and apply these properties that you should know, and let's solve them with equations, okay? So at this point, if you're listening to the recording, you've taken your quiz, and you're ready to go ahead and finish up the 8B practice, and you're going to turn this in for a grade, okay? And you guys sitting in front of me will as well. So looking at problem number 1, do I have information about angles, sides, diagonals? What's going on in my picture? A lot. I agree. I have X's and I have Y's. What else do I have? What that little degree symbol means that those things are what? Angles. Good. What do I know about the angles? And these are all about parallelograms, by the way. So what do I know about the angles in a parallelogram? Look at your property sheet. Look at the information. What does it say about the angles? What's congruent? If we have a parallelogram, which angles are the same? So let me give you an example. If I know that this angle right here is 120 degrees, I know all the other ones. I do. Yes, you do. Yep. I'm going to show you why. I know the opposite angle is the same, don't I? So I know this is 120. Let's use that and see if that would help us over here. Look at the opposite angles. Can I set them equal to each other and have a nice equation to use? Can I set x equals 2y? Is that a pretty equation to solve? No. No. You have x's and y's in the same equation. We don't want that. Okay? That's a system of equations that's a little bit beyond what we want to work with. We'd like to get an equation with one variable. So we're not going to use that property. But guess what else I know? I know that these two things add together to be what? Let me highlight it so you can see what I'm talking about. Maybe. Yes. The yellow circle and the blue circle, those angles are supplementary because I have parallel lines cut by a transversal. Those are consecutive interior angles. Do you remember that back from like December? No. Well, we need to remember it, okay? Because that's what's happening. So in a parallelogram, angles are either congruent, like the opposite ones are the same, or consecutive ones add to be 180. So wouldn't this one have to be 60 degrees? Would have to be. Okay. So, and this one would also be 60 degrees. So I'm going to use that to help me write an equation over here. I already know that I don't want to set those equal to each other because that would be tough. It gives me x's and y's together. I don't want that. So instead, if I look at what I have, can you see that? If I turn the lights out, maybe you can see a little better. There we go. If we look at those two blue circles that I've highlighted, those angles that I've highlighted, aren't those both have x's in them? So if I could write an equation just with those things, wouldn't that help me? What's the relationship between those? Are they the same? No, they're not the same because they're not across from each other. They're supplementary. So the equation that I would use would be x plus 5x minus 180 equals 180. The two angles, which I've underlined, so you should write this down, right? Added together equals 180. They're supplementary, right, Dom?
What is supplementary?
They add to be 180. That's what supplementary means. Make sure we understand the equation. Any question where the numbers are coming from? Now it's a matter of just solving it, okay? So at this point, we want to add like terms. So what do you see on the left-hand side that are like terms? 5x and x, right? So that gives me 6x. Now, a common mistake is that people see that minus 180 and just say, oh, it cancels. Because you see 180 on both sides. Don't do that. Don't fall into that trap. I need to add 180 to both sides. That doesn't go away. Right? So I have 6x is equal to 360. Right? And then divide by? Good. And x is equal to 60. Very good. Okay. So I would like for, and you're going to have to do the same thing for y. Okay? I want you to solve for y as well. So you're going to need to write another equation to solve for y. Think about how y's are related. Are they across from each other? Are they opposite angles? They're supplementary again. They're on the same side. So that would be that 4y plus what? 2y is equal to 180. And then it's a matter of just solving it. Okay? So I'm going to pause the recording right here. I would like for you guys to go ahead and pause it as well if you're watching this in the class. Pause the recording again, and then go ahead and finish 1 through 3, and then you'll turn this in. Okay? Let's do that. So you've just taken your quiz, hopefully, and now we're going to be looking at it's kind of like multiple choice practice on quadrilaterals. There are several of these questions, and I think that there's several types, I should say. And I'd like to at least go through one of each type, if that's okay with you. So let's start with problem number 1 together. I want you to think about in problem number 1 some keywords that you see. So when I look at problem number 1, what kind of a shape or which kind of a quadrilateral am I trying to make? A square. So if I was a highlighting kind of person or an underlining kind of person, that would be something that I would be highlighting, right? Square. We have a square. And then I'm going to go ahead and graph the other vertices. So I'm going to, and to me, I don't know why, but I don't like that these aren't really dark for me. So I'm just going to make them darker just so I can kind of see if that's okay, because I'd like to be able to graph accurately. So I'm going to graph the 0.51. Which is here. I'm going to graph the point 2, -2, which is here. We have -1, 1. And then we're trying to figure out where the 4th point of the vertex goes, right? So we're looking at the 4th corner, so to speak, of the square. Now, there's a couple of different ways to go about doing this, but since it is multiple choice, we can kind of graph the answers and see which one kind of makes the most sense. Can you visualize that my square, the bottom part, it's kind of like tilted on its side? Do you agree? It's kind of, it's moved a little bit. And so somewhere up in this area is going to be where my other point's going to be. So let's see if I can figure out what it is. -2, 2. Well, -2, 2 is here. Is that going to work?
No.
No. So we know that's not an answer choice. And we'll just kind of go through them. What answer choice looks like it might make the most sense? C, right? 2, +4. So if I look at that, make sure I graph it right. There we go. And then I go ahead and connect them. Does it look like it's a square to you? Yeah. How could I prove it?
Put the points.
Okay, so what do you mean? What am I counting? I'm okay with counting, but tell me what I'm counting. No, I mean, you're on the right track. I just want you to say what you mean. Devin, you want to add to it? So what am I counting is what I'm trying to say. Okay, so I could count to find distance. Well, when I count, aren't I finding slope? Not distance? Sort of. I mean, I'm okay with counting. Counting is fine. I just want you to be able to justify what we're doing. That's all I'm saying, okay? So I believe what Quabina and Devin are both trying to say is that if I count, let's say from here to here, and that means I'm going to be counting how far up and how far right I'm going. Would you agree? And isn't that slope, really? All right, so if I count, I go up 1, 2, 3, and I go right 1, 2, 3. So if I go up 3 and right 3, what's that slope? 1, okay? And actually, if I want to keep those same numbers, and then I go ahead and look at counting its opposite side, it had better be up 3, right 3 as well. And is it? It is. So both of these sides that are highlighted in yellow do in fact have a slope of 1. Good. If they are perpendicular, which means they have right angles, what should the slopes of the other two sides be? -1. Remember that perpendicular lines have opposite reciprocals. So that means that I'm going to flip these numbers, 3 over 3. I'm going to flip them and make them opposite sign. So we're expecting it to be -3 over 3 because I flipped them and made them negative, right? So when I go ahead and do that, and I count from here to here, don't I go down 3, right 3? So I do have this. So we have perpendicular sides. I've proven it's a square. Okay? The lengths are the same, all the sides' lengths are the same, and the slopes are perpendicular. Good. You'll be doing this for a couple of things through, so we have a parallelogram is a key word in the next problem. So it's a little bit different, okay? It might not be a perfect little symmetric square, but it's going to be a parallelogram. You have another parallelogram. So we're looking at counting, and I'm fine with that, Quabina. You were counting. We're counting the slope of the sides. How far up and right or down and left or whatever it is we're doing. That's okay. I'd like to, and problem number 7 is very much like that. Again, we have a parallelogram. We have a parallelogram. So you're looking at process, and that's okay. Can we look at problem number 5, though, because it's a little bit different than the others. So find your number 5. Flip to number 5 in your problem. Okay? So in problem number 5, this one's different. Why? Look at the answer choices. They're letters. You're going to possibly see something with letters. So we're on number 5, Quabina. Instead of the numbers. So when we think about just counting, we have to be careful, okay? So if I'm starting at the vertex here with point Q, what is the distance from here to here? Well, from 0 to C. So isn't that just length of C? Like if that was the number 40, wouldn't that be 4? If this was the number 70, wouldn't that be 7? So just whatever that C is, the distance of that side is C. When I think about the distance going up here, up to point R, how far up do I go? When I look at this A and this B, what's the up? It's the B, right? So this distance is B. When I think about S, aren't I going up the same amount? So isn't this going to be B over here? Okay, so what answer choices can I eliminate?
B.
I can cross that answer choice off. When you have multiple choice, it's a good idea to eliminate answer choices. So now what I'm looking at is what my x coordinate is. Well, when I think about this distance being C, if it's a parallelogram, isn't that also C? But it's not just plain C, because don't I have to add that much to it? So it's C plus another amount, and it's C plus A. Very good. So the answer is D. It's kind of weird with letters, don't you think? It's a little uncomfortable. You're doing the same thing, it's just letters instead of numbers. Luke, put your phone away. Unless you want me to talk to whoever you're talking to. Yeah, I don't mind calling her, talking to her about your grade. That's totally fine. I'm good with that. All right, let's try number 7. Number 7 has numbers, so maybe it'll be a little bit more comfortable. It's the same kind of idea. Let's try number 7. Go ahead, you try it. You look at number 7. Keep going. Look at number 7. It's the same process, but this time it has numbers, not letters. We're going to go up the same amount. How up high are we going to go?
3.
So don't we have the answer right now? We know that we're going to go up. This distance from here to here is 3, which means this also has to be 3, which means which coordinate's 3? Yeah. And isn't the only answer this one that has that there? Like we're done. But did we understand where the 7 came from? 5 plus 2. Because this is 5 from here to here, and this over here is 2. So 2 and 5 is 7. Yes. Because that's how far up you go. Because it says here, point A goes up 3. Right? How do we feel about those? Okay? Okay. All right. So you're going to be working through some of these problems. We also have some property questions I want you to think about. I would like to look at, we have some problems here. Let's look at problem number 9. Let's set that one up for you. Problem number 9. Let's set up problem number 9. You don't have number 9? Oh, this whole problem's got skipped. Interesting. All right. Well, for now, I'll come back to these, okay? And so we have to skip this page all the way to number 17? So we missed a whole page. I don't know. All right, well, let's look at 17. I'm okay with that. What kind of a shape do I have? A rhombus. It's a rhombus. Special things happen in a rhombus. Tell me some properties that are specific to a rhombus. Give me one, Kisei. That's true for any parallelogram, but what's specific to a rhombus? Amelia? That's really important. The diagonals are perpendicular. So you know what I'm going to do? I'm going to go ahead and just draw that in. Good. What else do I know about a rhombus? What's true about all the sides on the outside? They're the same. Okay? So let's see if any of that information is helpful. So when we look here, it says that AC is 30. Oh, wait a minute. So if AC is 30, don't I know that each of these is 15? Why? They bisect each other, so they are cut in half. And we know half of 30 is 15, right? Let's keep going. It says BD is 40. So 20, 20. I agree. Are we okay so far? What kind of a shape do I have here? Be more specific. A right triangle. Can I find that side? Will that help me find what I'm looking for? I'm looking for the perimeter, right? Which means that if I find X, and we know they're all the same, when am I good to find the perimeter? So let's find X. So what equation, and we talked about this last class, what theorem will help me with right triangles? Yeah. So we know that 20 squared, and when you turn this in, I'll be looking for this work, not just circled answers. So it's going to be important that you just don't guess and circle answers and turn this in. So 20 squared plus 15 squared is equal to x squared, because that's the hypotenuse, right? Okay. So you guys have calculators. Oh, well, if you could grab one if you don't have it. Well, we'll just do it together. 400 plus 225. And so that's 625. And then if we take the square root of that, 25, right? Okay. So notice that 25 is an answer choice. Darn it. They put it there to distract us.
They're trying to trick us.
Right, because we don't want the one side, we want all four. So what's the perimeter? That's right. Good. 100. Okay? Say, huh? I'm not going to say it again. 100. Don't do that ever again, Miss Mackert. Ever. Got it. Yeah, I say stupid stuff like that, and my teenage boys, because I have an 18 and a 16-year-old, they're like, calm yourself, Mackert. Okay. So, you have a few minutes left. I don't expect it to be all complete, but it will be due next week. Okay? So you can take it home and work on it. What I don't want you to do is to just circle answers and give it to me, because all these problems require work. I need to see the work. Okay? So this is going to, you have answer choices that, I mean, some of them don't. Like number 19 doesn't require work, because it's just a property, right? So the property questions you don't have to worry about. But the ones that require work, the ones that have numbers, I need to see it. Otherwise, you won't get credit for that problem. Okay? So, huh? No. Guessing doesn't get you anything. Not here. I want to see work. Okay, so you have the rest of the class period to work on this, and then you'll turn it in next class. Okay?